Please note that anytime during this discussion, you'll have the opportunity to submit your questions to our panelists. To do so, type your question into the Q&A section at the bottom of your control panel, and we'll set aside some time at the end to answer your question. So today we are joined by Dr. Xiaoyan Wang, the Chief Scientific Officer from Melax Tech, which is now part of IMO. And I think I'm gonna pass it on over to you, Xiaoyan.
Thank you so much, Judy. So just a little bit, about myself. Xiaoyan Wang, right now Chief Scientific Officer of Melax Tech. My previous life, I have been a professor at UConn Medical School for about 10 years, and then I moved to Mount Sinai, and it's also the company spin off from Mount Sinai Medical School, which is called Semaphore, now called GNDX. So I had the privilege to witness how NLP was utilized in both academic and medical system settings and also industrial settings. So I want to share some of those experiences with the audience today. And this is the title of my talk today. I really want to emphasize, give me one sec to show this off. So to share with you, in this area of AI, NLP, how NLP can bridge and fill all the gaps from quality data to meaningful insights. This is my disclosure agenda for the presentation I'm organizing today. So I will start to talk about quality of data. So how are we gonna start to control the quality of the data at the time of point of care with process terminologies. And then I'll move to AI and NLP in healthcare. So what are the challenges we're having and how it works NLP-wise, using NLP to really change the quality of the data and also meaningful insights, how NLP works mechanically. Then I move to the meaningful insights powered by NLP with a couple of disease areas such as neuroscience, oncology, immunology, rare disease, and a couple of other diseases. So the last portion of it is the most exciting ones because large language models represented by ChatGPT, which made everything in public very exciting about NLP itself. So it's never like this in my career of doing NLP for about 20 years. So every day you wake up, there are new models comes up, there are new applications built up, there are just a lot of excitement in the area. And I love to share with the team here. Then I will conclude the talk. So I'll start to explain a little bit on quality of data at the point of care. I'm sure, our previous speakers in this series have talked a lot of, how IMO as an interfacing terminology at the point of care when physicians, providers provide care to their patients, how we as terminology companies really support the quality data at the point of care. For example, when physicians start to document everything precisely and deeply and granularly at the end, that facilitates a lot of quality data. Another point I like to make is the interoperability. The reasons being that, beyond the point of care, there are a lot of downstreams such as, terminologies, ICDs as a billing code and also SNOMEDs. And there are about, last time I counted about 400 terminologies in healthcare and how they talk to each other. So actually we also facilitate that feature using, the mapping between different terminologies. So this is briefly how terminologies at the point of care can support quality data. So this figure, I like to show you that in this area of AI, how NLP really enables quality of data and also meaningful insights. So as you can see, there are actually, I draw just 4 lines here just to show a couple of examples. There are lots of cases can be done, applications can be done in this line. So something like, if we normalize NLP, for example, we extract all the text from notes and encode them into standard terminologies. So everything will be normalized and standard. That's one way of improve quality of data. The other thing I listed here, this is also our internal project called an undocumented diagnosis, because there are lots of new information hidden in notes. They are not coded. So we can actually run through all the text to get those things coded as the information to support the care deliveries. So those on the quality data side of the story. On the other side is a meaningful insights. So I list here, one is clinical trial, how we actually support clinical trials and drive insights there. And also another thing which I spent most of the time today talk is the thing I call text to insight, how that supports meaningful insights. So again, there are lots of stories we can talk from, how NLP AI can support both quality data and meaningful insights. Even for those 4 lines, I can just talk 5 hours on each side of the story. But today we just focus on the text to insights. So next session, I'll move to AI and NLP in healthcare. So I want to start this one because I found quite some people in the fields even have been using the terms such as AI, machine learning, deep learning, NLP, large language models, all interchangeably. They're actually quite different as I list out here. So AI is a much bigger space. Machine learning is part of it, and deep learning is one component of machine learning. NLP is a combination of both learning, machine learning, deep learning, and also computational linguistics. The recent very, very popular ChatGPT, which is also a category of large language models, lies here. So this is basically, how the different terms. I do want to also point NLP is the most challenging problem in the field of AI because language are very ambiguous and very complicated to understand. So NLP has been considered as the peer of AI crown for many years. So now in the next couple of slides, I want to show you the challenges we've been having in healthcare on data ends. The billions of dollars have been spending in health systems. However, we haven't really utilized all those data too much in the past 20 years. So why is that? This is the story I wanted to share on the left end. I want to show you the richness of the data we have in the health systems. Think about it. When the patient come into encounter, visits the doctor's office, goes through all the care process, every step is documented on what disease he has, what medications he's prescribed, and lab tests, all those things are very well documented in the health systems. This one, I know you cannot read it, but this, I just want to show you, there are a lot of tables, structures, architectures behind, just the interface of charts to supporting on that. To give you an example, there are about 15,000 tables behind Epic supporting all that. I've been joking to my colleagues as I'm probably the only one opened up all those tables in the past years to really find out where everything is stored and how they stored and how I can utilize it. So that's a richness end of the story. On the other hand, it's very heterogeneous. So literatures have been piled up to show that 80% of clinical information existed only in notes. They are not structured and they are not ready to be utilized. So that's what NLP really plays here. Here is the examples I want to show you, what really NLP does. On the left end, you see it's a text document, precisely, they are there's oncology pathology reports. As you can see, it's a standard text, sometimes with even manual writings here. So there are lots of information about the patient's information. The question has been, how can we really utilize those data, get those data extracted meaningfully, structurally, normalized, and also standardized and encoded into standard terminologies. So the challenge has been, can you do it? I think the simple answer is yes, we can do it. Then in the next 3 slides, I want to explain you how we actually do it. So I think lots of people think NLP is extremely complicated. It is true. As I just explained, that is the peer of the AI crown. It's very hard to reach. On the other hand, it's very simple. Think about it, as a human being, how we understand this word. Really 2 things. One is, what are they? That's entities. The other is how they related. Those are relations. So entities and the relations are the way we really understand or domain knowledge. So that's why it's the first step when we do NLP, we always construct either called information schema or ontologies. For example, this is the one ontology we built for the pathology report, as you can see. So we want to capture things like body set. Is that breast cancer, lung cancer, or other type of cancer? Or what is the TIM stage of the cancer? What are the invasion or metastasis part of it? What are lymph nodes involvement of the cancer? All those are attributes of those entities we want to understand. So this is how we document an human or domain experts' understanding. We annotate things like what are the entities and how they related. So this is one of the results on the oncology pathology report. As you can see, lymph nodes was recognized as body sites. Metastasis was recognized as a tumor invasion, and then 3 of 26, those are value. And those, as you can see, how we really recognize what are they and how they related. So after we finished all the documentation on human understanding or domain understanding, the next thing we do is we teach the machine to learn all those findings. So the machines are those, technologies. So here I'm showing you just a quick line of, there are lots of big advancements happening in the past 10 years, especially, from the word embedding to transformers. GPT, as I said, GPT is now a pretty public word because of ChatGPT, but it's appeared 5 or 6 years ago already. So until 2020, and then ChatGPT is GPT 3.5. So those are technology, and then we have the system called CLAMP. It really documents, show you how to build NLP pipelines. So we actually made it very simple. You can just really grab the things, how you want to do, text selection, sentence name tokenization, and negation, blah, blah stuff to build the pipeline. And this is one example of the architecture we built to do imaging biomarker called ground glass opacity. And for simple phrases like ground glass opacity in the right apex, this is a very simple phrase. The first thing we do is we send into the embedding, so which actually transform this phrase into about 200 vectors, which stores all the information and the sequencing information. Sending to the deep learning layer, this is about the action STS model. So learning all the contextual information forward and backward, then sending to CRF level, which is the prediction computation on what are they and how we label it. At the end, you get the labeling. And after all that, so you want to see, how you realize all that. We also have another tool called Vital to really realize, let's see, for a particular patient, if you hear one symptom or signs across his or her journey, and we actually make it searchable across millions of the data, get out all standardized already. So there was lots of analytics dashboard built on this as well. So I think that finished the first section of my talk today, basically showing how NLP generally works. Next one, I'll move down how we generate insights from those technologies. So I just want to simply summarize again, how we from text like this, everything is recognized on what it is and how they relate it. For example, HTN, which is a hypertension, recognize a problem or conditions or diseases, and then encoded into standard terminologies. It's standardized in those terminologies and then generate insight at the end. So this is a pretty graphic representation on how we support research using NLP. So there are two quality index here. One is getting deeper, the other is seeing more. By getting deeper, as you can see, the granularity we can really drive on patient journey. So this is a patient journey show, because again, 80% of clinical information existed only in notes. So by using NLP, we're able to extract all those information at the point of the patient to get birth, and then all the symptoms, signs, triggers, certain screening steps for diagnosis to the time it's actually diagnosed, and a follow-up on disease progression and treatment outcome as well. So this is the whole patient journey. On the other hand, we actually establish a federated learning environment to deploy this algorithms to different medical centers, to test and optimize. So this has been done in the research network already. This is one example showing you, the strengths of using NLP and also federated learning environment to build a patient. Using rare disease example because, the sample size really matters for rare diseases. As you can see, we can build a lot of disease and, start to compute the disease phenotyping and treatment patterns, outcome analysis because of this research network. And this is actually how we do it. For each health systems from their source data after ETL, everything is standardized into common data models and then adapt the federated module and go through each and optimize and then send to another one and the third one. At the end, we'll accumulate and the evidence will be disseminated. In the next couple of slides, I want to use one case study to show you how it works. So this is a research I've done with my colleagues who are wonderful, dementia experts. They both physicians and research. So they've been doing this dementia research for about 30 years and have lots of publications, grants on dealing this. And one day, the director center of aging came to me, said, Xiaoyan, you've been telling me you're able to unlock all the notes and got all those insights. I have a question I've been wondered for 30 years, has not been able to answer it, which is, from the time the patient first complained their memory loss to their providers to the point the patient get diagnosis, what is the time duration on that and what are the risk factors plays in that trajectory? This is the ontology we built to extract those information. So we started the concept of memory loss to track how long it has been, duration, and it's getting worse or better. What are the co-occurring symptoms, and also when that happened, is how the cognitive test is done. And dementia is a particular disease need a lot of family supports. So what are the caregivers related to the patients, and also what treatment has been done even before the diagnosis? Because in the areas dementia, there is a treatment indicated diagnosis. So if they respond to certain medications that actually lead in the diagnosis. So this is the information schema. And this is a notes. It's not a real notes, it's a made notes to really show you how it works. So basically for the concept of memory loss, as you can see, it recognized as a symptom, and then it's getting worse. It's been 4 years, and his or her, it's actually her son has been taking care of her, and it's getting worse, and she's on certain medications. All those things documented in notes. This is how it works. We basically going through millions of notes, go through and to annotate, to put our domain understanding into those notes, and after NLP will be processed, as you can see, it will be standardized with the semantic relations and ready to be analyzed. There are lots of exciting findings from this study. I just want to show you one, and I think it's very interesting because this focus on this one. So using husband as a reference standard, if wife being the caregiver and their husbands get 249 days earlier diagnosis than the other way around. I think we know like women pay a lot of attention to details, but this is really scientifically shows how it works, and it's actually true. So this is an example in oncology space. In oncology space, it's very challenging to build up the real patient journeys, track the disease progression, because it really runs quickly and lots of things can happen at the same time. So again, as you can see, this text here really contains all the information about what is a diagnosis, when that patient have the surgery and what is it, and how the adjuvant therapy happens, and recurrence metastasis happens, and what time is it, and also the systematic therapy on those patients. So everything can land up using NLP, and you can compute your overall survival, progression-free survival based on this data. This is a systematic way, shows the difference with or without NLP. Without NLP, most of the study really just be able to capture what is the first line, second line, and also the patient is live or yes, no. So using NLP, you unlock so much rich data and to getting things a lot insightful. So this is the slides I'm trying to show. I showed you neurology, oncology, but I want to show it's actually in every domain of the disease you can do that. So those are I am showing you different studies that have been done. So this is in the leukemia space. We follow up on each patient. What is what he or she had, the first line to second line. And this one showing population-wise in a cohort, how population moves from first line to second lines, and this is in the immunology space. And this is the one we capture the landscape of non-small cell lung cancer treatment for last 10 years, as you can see, because all those very exciting findings of PD-L1, the immunology therapy and all that. So there are a lot of trending, rich trendings here. And this is in a rare disease, we're able to track disease progression. So there are a lot of this, as you can see, and all enabled by NLP. So I think before this, what I've been showing you, all those insights generated from clinical notes. There are a lot of other biomedical text, such as literature, social media, and all that. So I want to show you one by one. Another one's a couple of those. So this is the one in the clinical trial criteria. So clinical trial, that is, what to use to recruit patients. So basically, it exists in text. So using the text, based on the text, using NLP, we're able to pass that everything structured. Age, we interpret as age to in what degree, in what range, and also lab tests in what range. So everything is now computable. So we're able to, for every trial, every patient, search through every criteria the patient pass or fail. That criteria make them eligible, yes or no. So this one showing in our database. So how many patients, across for last 20 years, those are all different trials, how many patients really eligible for each specific trials. So everything, because of NLP, everything is now computable. This one showing the social media listening tools we've been built on the left, and so it shows you some of people's opinions on vaccine, especially vaccine being such a big topic in last couple of years because of pandemic. So people believe it or not believe it, how that news was spread, and at the end, how that really affected their uptake on vaccine. So we pass through all those posts, 80 million of those posts, able to find the trendings and also how that associated with the real world vaccine uptrending. So literature, this is another rich resources of biomedical text mentioning a lot of information. So we're able to build the tool using NLP, pass through all that, and then get all the interested data elements structured and analyzed. Build upon the literature, we also incorporating lot of knowledge sources, able to build a knowledge graph in biomedical NLP. The user cases on this are basically new knowledge findings based on existing knowledge, what new knowledge you can generate. One of the user cases is drug repurposing, thinking about, pharmaceuticals companies spending millions, billions of dollars, find some compounds they are testing on clinical trials and how it works, yes, no. At the same time, they also wonder how I can repurpose this compound to other diseases. So this is really the way to do it. So I think I've been showing you all those different kinds. There were a lot of those, text from clinical trial, from patents, literature, health news, all those things putting together is extremely powerful. And this is the work in progress we've been building on the insights generation. All right, I think I showed a lot of insight generation using text and NLP. Next, I'll move to the pretty exciting topic on large language models represented by ChatGPT and how that really works in the whole healthcare and innovates all the findings in healthcare. I want to show you this first because this is really show the AI, another AI rush is coming because of, as you can see, so in all those earning calls of public companies, AI is spiking up in the first quarter of 2023. And ChatGPT really hits a lot of areas, and healthcare is not the exception. So the first sign of ChatGPT hits healthcare is it passes US MEDI test, which many very good students, including my own students, was not able to pass it. So that is really gets me and a lot of my colleagues excited. We spend a lot of time. I think I want to share you, like for last 6 months also, every day I spent like 2 hours to really follow up all those methodology, technology updates in the fields and also application ends. So on the left end is the first end, and this is one of the examples of the user cases empowered by AI. So this published a couple of weeks ago. Just want to quickly show this because it's fun. This is really showing you large, what large really means. As you can see, the parameters embedded in the model keep increasing and enables lots of functionalities of NLP, starting from language understanding and to translation, to QA, to summarization, and a lot of NLP understanding here. This is another way to look at it. This is being built by Hu Xia, who is a colleague of mine and at UT. So again, GPT started around 2017, starting from the very famous paper, Attention is All You Need from Google. Actually, Google is a company really made a lot of innovative fundings. It has all those fundings now built together by OpenAI, but they actually did all those fundamental works behind all the ChatGPT stuff. So those are showing you, they're not ChatGPT is not the only one. About a lot of those large language models all have their strengths and weakness on taking care of different type of tasks. This is a little bit technical, but I do want to show you because I think it's pretty fun. Like it basically shows you, the computation space and also the parameter increased to this degree, 10 to 22 degree, the performance of the system just rise up quickly. So this is the paper published about the same time of ChatGPT release. So it's really interesting phenomena in the field of large language models. Okay, in the next couple of slides, I'll show you quickly how those examples, how the large language models really facilitates or changes how we do NLP. So on the left end, you can see this is a patient safety report. It's pretty dense text, and so large language model is being able to pass everything as a safety journey report and rating. So research protocol rating has been very complicated and time consuming. And you can actually now ask GPT to do quite some of those. Even more recently, if you give it a very structured way to inform how you want the writing to be, it actually writes the whole paper. Of course, it's not a perfect or even not a good one, but it's a very good starting point. Patient journeys, on left end shows you how, cancer patient was taken care and what kind of characteristics of his tumors. And on the right end, everything is now passed with timestamps as well. So this is the pathological findings. This is again on the left end. Those are the oncology pathology findings. On the right end, you're able to see, okay, it's a lung cancer, it's a squamous cell lung cancer, and also what is the TLM stage, and also what are the tumor size, and all that's been able to process. So literature is another thing, and it can be done quickly, really analyze. So what is the cohort? What is the cohort size? What are the arms of clinical trials? What are the interventions? And what are their endpoint analysis in terms of, hazard ratios, even p-values, etc. Clinical trial, again, this is how we actually doing this right now. And we actually had a paper just submitted on, we call it auto criteria using large language models. And we actually sending it to Melax, which is our NLP systems in house right now. So basically what you do is you give it an NCT number, it just immediately within a few seconds process all the annotated text and also structured text just in a few seconds. So I've been talking a lot of excitement about the large language models, but any research or any science will not be done without limitations. So there are there are some limitations on large language models as well. One thing is very famous, we call it AI hallucinations. It's really how it sounds like because it make up stuff. This is the example I sent it to write CAR-T therapy in multiple myeloma with references. It actually writes pretty nicely, but the first literature it gave me, it's made up. This is not a real literature. I also want to see that, yes, it made that stuff, but especially in right now, the GPT-4, which is another version. So ChatGPT was 3.5. Right now, the updated version, GPT-4 actually function pretty nicely. So I think they're taking care the hallucinations much nicer. So there are a lot of other limitations. One big one is transparency. For example, ChatGPT, we know it works really well, but we actually don't know what data has been used to train the model, which is sometimes kind of suspicious because you actually don't know what bias hidden there and when you derive some insights, and what should you be really willing to understand the bias and also challenges on that. Security issues, this is a very famous example in the community. If you pump it enough, you're able to really get those either HIPAA or security information out. There are lots of limitations we probably don't have time to go through today. There's a very nice paper published just a while ago on a survey on this. Actually, myself, I organized a webinar about February, and then about 200 people attended to that. We also did a survey, showed the similar concerns and biases on this. Again, there are a lot of findings, papers have been published in the last couple of months. I want to be able to go through one by one. Maybe I can start with TwoFormer. TwoFormer is a program. They actually able to instruct large language models to teach calculus stuff by itself. And there was another study shows, ChatGPT actually shows 8 years old cognitive test. They actually passed all that. So it's pretty scary. I think they are like human beings now. So I think, I talked a lot of those already. I want to come back again to the quality data to meaningful insights. This is really how I see it. So we start with quality text, and also with all the impressive powers of AI models, and with the human understanding on the problem you are to solve. So all those three together, we can get all the insights needed for research and clinical care. This is a paper just published a few weeks ago on, what kind of futures we're going to have in with all the AI technologies. So I'm a strong believer on technology, and I think a better system are coming. So I know I'm the only one really talk about all this, but really I have many beautiful teams have been working with me on that in the past and current. So we don't have time to go through those publications one by one, but if you want to read it later, you can do that. That ends my presentation today.
Awesome. Thank you so much, Dr. Wang. All right, so at this time, we'll get our Q&A going. So if you have any questions coming in from today's webinar, or anything that Xiaoyan has mentioned, please enter them now and we'll begin to answer them live. Just please excuse any brief silence for us to look them over. All right, Xiaoyan, one came in. I'm an MSHI student interested in NLP. What would you recommend that I study to get into NLP, and how can I break into the field?
All right. To get into the, depending on what you want to do, there are a lot of directions you can do. So I think because you attending this seminar, you probably want to do something in healthcare. And also there's a big sectors. There are a lot of sectors in healthcare, the hospital ends, the technology ends, and the pharma ends, all those kind of stuff. I think right now, because large language model really changed the way we do NLP, I really suggest if you want to focus on one particular sector of it, start to understand the domain itself. So that's really the starting point. And then get to the large language models ends to apply your knowledge into the model, and then data ends. Really, this is a very generic question. I don't know, what is your future directions you building your career into, but if you want to talk about this further, I mean, we can talk offline on that.
Awesome. Yes, the recording of this will be shared at the end of the week in the follow-up email. All right, one person wants to know how you annotate your training data. Do you use any auto annotation tools? Would you recommend an auto annotation tool that has good performance on clinical data?
Very good question. So They are quite some of the open source annotation tools. They actually works well. Depending on, we actually have one called Line in-house. We're doing NLP. We build that to ourselves for our own needs. The reason is because we actually work on lots of NLP tasks. So we need team support. Basically, there are hundreds of thousands of annotation needs to be done. Oftentimes need one part report goes to 2 or more annotators. So we need to compute agreements between annotators and all that and compare, how the annotation agreement is, and also all those tasks. So we actually support the team annotation using our tool. So the short answer to your question, we use our internal build tools. If you come from a research community, it's actually, I think it's actually free to use. Let me check with my legal team to see if it's free to use. I think so. Yeah. After that, answer the question.
Okay, another question. What are the compliance issues associated with ChatGPT or other large language models in healthcare and life science industries? And what do you think we can do to address them?
I think I briefly mentioned the training, the models, the model trains on certain data, and those data oftentimes is just selection of, some of those targeted data you want to understand. So how you actually select your sample to annotate, that is really one type of a bias likely to have. The other is also you do your sampling, and also how you really instruct your annotators to understand it. So how you build your ontology to guide all those annotations, because the way you want it's annotated A or B way actually cause differences at the end of quality and also the NLP performance as well. And those are, different kind of biases likely to have if you don't handle them well.
Okay, another one came in. Are there large language models that can be used internally in an organization that allow protection of intellectual property?
Okay, very good question. I think right now we talk about a lot of, those we use ChatGPT, GPT-4 to do it because it's very powerful. But you have to access their API and then send your data and process. So you cannot send the patient data, for example, to there. So because of privacy issues. So the solutions are different ways. So one way is you can, I think right now there are a lot of organizations work on, call it localized, customized language models. So in the future, I don't know how soon it's going to be. It's going to be everybody have your own customized, localized large language models. And the model doesn't have to be that large for particular needs in general.
Awesome. Okay, another one. How do you think IMO's install base can take advantage of these new NLP tools?
I think actually I worked with some colleagues the other day, showed how we process clinical trial data and generated the output, which is very well structured. I think my colleague immediately said, this is actually the value sets of clinical trial, at least the starting point of this. So olden days, we actually do it manually, but now you actually can do it automatically.
Great. Okay, this is kind of a long one. So what are the best practices in managing training data and keeping models trained up to date? Adding new training data, removing old or outdated or just found to be incorrect training data? Like what frequencies do you think we should be used for these changes? Like, is it weekly data, like daily, monthly, quarterly?
Okay, I think let me see if I understand this question clearly, because I think you're asking the training data doesn't need to be updated because you have a task to do. So, and then you select a sample size for annotation and then build models and then process it. That's the general process. So once your model is built, you already done. Annotation usually does not need to be updated, but I think you probably target another question, which is, okay, originally I selected 200 samples to do the annotation. Now my model performance is not good. Then I'll go back to do it. And then I want to do another 200 or 300. How do I do it? So it basically follow the same sampling methodology you use. Just to make sure it's representative to the target population data you wanna represent. That's it. Training data does not need to be updated because once it's built in the model, you can just use the model.
Awesome.
Model updates just, when you compute the performance, if it's not that great, then you just update your model with the data. You just select another batch of representative sampling data.
Okay, another question. Thoughts on what this might all mean for medical writers in the pharmaceutical industry?
Okay, the rating part is very interesting. They actually have a lot of papers published in the fields. Do we still need a medical writer? Because GPT already done lots of fun writing already. I myself, actually, it's a better writer than myself as a non-English speaker. But it's actually I think it's a good starting point. Yes, I think some of the low quality writers may have to be replaced by ChatGPT, for example. But there are still a lot of high quality or domain specific knowledge needs to be injected into the writing. I think a lot of careers probably will be impacted with large language models or generative AI. But embrace it. That is the future. If you don't use it, you will be replaced by people who use it.
Mm-hmm. That's a good point. All right, Xiaoyan, I think we're going to close this out today. So thank you so much. We're going to close out. I will send a recording of this webinar along with just a follow-up email. If you have any questions, please feel free to email our sales team at sales@imlhealth.com. We hope you found the information in today's webinar useful, and I hope you have a great rest of your day. Thank you so much.
Thank you.